This video will cover 7.1 in geometry over ratios and proportions. First, we're going to start out by defining what a ratio is, and that's just a way to show the relationship between relative sizes of two or more values. One common example of this in math is slope on a graph. Slope is rise over run, or the change in the y's over the change in the x's. Okay, and so what we're doing there is comparing how much rise we have to how much run on our graph. So ratios, if we're looking at them, as you can see below here, can be expressed in a couple different ways. One of these ways is by a fraction, and then this next one over here to the right for number 5, they can also be separated just two numbers with a colon in between them. Okay, all of these are just ratios. Well, just like with normal fractions, we want to make sure that our ratios are simplified. So for ratios to be able to be simplified, we have to make sure first that we are comparing numbers with the same measurement. Okay, so that's what this must have a common label is going to mean for us. On number 2 here, we're working with centimeters on the top and centimeters on the bottom, so there's no issue there. We can go ahead and reduce this 60 over 200 like we would normally. Since there's a 0 on both, we can just get rid of those extra ones, and now it's 6 over 20. A 2 goes into both of those, so we're left with a 3 centimeters on the top and 10 centimeters on the bottom, and that's as simplified as that ratio can get. Now, I'm going to leave those centimeters on there, that way we know what our ratio is being measured in. Those labels will be important for us. Same concept for the next one. Again, we're both in feet, so it's okay to simplify like normal. And extra zeros we can just get rid of, and that is 1 foot over 12 feet. Nothing more we can do to that one. Now, notice on number 4 we've got feet in the numerator and then inches in the denominator. So what we have to do is change one of these so that we're in the same measurement. Now, we know that 1 foot is the same thing as 12 inches. Well, we don't have 1 foot on the top, we have 3, so we can say that's 12, 24, 36 inches. Then on the bottom, 18 is already in inches, so we will leave it like that. Now, since we're in the same measurement, we can go ahead and reduce, and 18 goes into both of those, so we've got 2 inches on top and 1 inch on the bottom. Now, normally we could say 2 over 1 was just 2, but ratio, we're comparing two different numbers, so we want to leave it as this 2 over 1. Last one of this type here, we've got 5 meters to 20 meters here. Okay, just like with our ratios here, we're in the same measurement, we're good to go. We just have to make sure that there's not something that's shared with both numbers. In this case, we've got a 5 and a 20. A 5 goes into both of those, so I've got 1 meter and 4 meters. Okay, all of those are just different ratios as simplified as we can get them. Now, on the next couple problems, we're kind of working backwards from what we just did. We've got this diagram here, and AB is being compared to BC. Well, that is just the two different segments that make up the big segment AC. Now, the ratio of these segments is 4 to 1. And then we're also told that AC is 30. Well, if you notice, this is 4 and this is 1 according to our diagram here, AB being 4 and BC being 1. However, those definitely do not add up to 30. What that means is this 4 to 1 has been simplified just like we did up above in those problems. What we need to do is figure out what was it simplified by, or what factor did we reduce both of those segment lengths by to get down to 4 to 1. In order to figure that out, we will just say, well, 4 was multiplied by some factor, and so was 1. And we know that 4x plus 1x are two segments will add up to our larger segment, which is AC, which we were told was 30 units here. So then we've got an equation where we can find that scale factor. 4x plus x is just 5x, and then equal to 30. If we divide by 5 on both sides, we have that our factor is actually 6. So if we want to find out the length of AB, we would just say 4x is the same thing as 4 times 6, which gives us a length of 24. Very similarly, we can say BC, that was just 1x, or 1 times 6, and that gives us a length of 6. Now we have two numbers that actually add up to be 30 like we wanted them to be. That's one way you can check yourself, is just to go ahead and make sure that the two numbers you are given add up to what you wanted them to be. Another way is we said that this 4:1 was our reduced ratio of our segments. So what that means is my two actual segment lengths should reduce to this 4:1. So I'm going to write the ratio directly below this one above so we can see 24 to 6. If you notice, if we take a 6 out of 24, we get to 4. And if we do the same thing and take a 6 out of 6, we do get to 1. So those are our side lengths. Okay, so for the next one, we're going to do very similar process. We are told that EF is compared to FG in the ratio of 2 to 1. So EF is 2 times some number, and FG is 1 times some number. Okay, well, we're also told that EG, this whole length here, has to be 30. So if we want to set up an equation just like before, we will say 2x plus 1x equals 30, which is just 3x equals 30. Divide by 3 on both sides, x equals 10. That is the factor that the 2 and the 1 have been multiplied by. So if we go back up to our two side lengths, EF should have been equal to 2 times x, or 2 times 10, and that gives us 20. And then FG should have been equal to 1x, or just 1 times 10, which is 10. Okay, two checks again to make sure we did this right. 20 plus 10, we better get to 30, and that's good to go there. Another thing, if I put this 20 to 10, it better reduce to the same exact ratio I was given to begin with. And 20 to 10, if you take a 10 out of both, you sure do get back to that ratio. So we did our job correctly. Those are our two lengths that we were looking for. The next problem is talking about perimeter of a rectangle, so I'm just going to go ahead and sketch a rectangle on here. Now, the perimeter, if you remember, is just the distance around, and we've got that's going to be 80 feet. Now, we're told that the ratio of length to width is 7 to 3. Again, 7 and 3 are not our actual side lengths, because if you try to say 7 plus 7 plus 3 plus 3, we definitely don't get up to 80 feet. What we want to know is what are the actual length and the actual width of the rectangle. Well, just like before, instead of calling the length 7, we could say that's 7 times some number, or 7x. Very similarly, for the width, we can say that's 3 times some number. Well, if you remember, the perimeter for a rectangle can be written as 2 times the length plus 2 times the width, or 2 times just length plus width. Those are equivalent. Now, I like this last one because we were originally given the length and the width, 7 and 3, so it makes our life a little bit easier when we go to solve this problem here for x. Now, I'm going to go ahead and substitute P is actually 80 here. And then there's two ways we can solve this. Normally what we want to do is simplify what's on the inside first, and I'll definitely do that. And we've got 7 plus 3 is 10x equals 80. Now, two options. We can either divide by 2 and say that's 40 equals 10x. Notice that gives us smaller numbers to work with. So x equals 4. Or we could go over here and say 80 equals, well, 2 times 10 is 20x. And then divide by 20 on both sides, and we get x equals 4. Same answer, two different ways, whichever one you are more comfortable with here. Now, based on that, that's just our factor. We need to go find our length and our width again. So our length will be 7 times x, or 7 times 4. That gives us 28. In this case, since our perimeter was measured in feet, we want to make sure that we tack on that label there as well. And then our width is 3 times x, or 3 times 4, which gives us 12 feet. So length and width, just like we were looking for. Again, there's a couple checks that you can do to make sure you did this correctly. This was 28 on the bottom there, 12 and 12. If you add all those up, you better get 80 feet. Other check we can do, 7 to 3 has to be the same ratio as 28 to 12. And you notice a 4 goes into both of those numbers and reduces down to that 7 to 3, just like we needed it to. Okay, so what I'd like you to do for the next one is go ahead and pause the video and see if you can set up number 9 based on what you did for 8 there. Okay, first step is go ahead and sketch yourself a rectangle. We know that the perimeter of this rectangle has to be 84 feet. And it tells us the ratio length to width is 4 to 3. So I will say that's 4x and 3x. Remember, perimeter, we can say 2 times the quantity of the length times, or length plus the width, excuse me. And then fill in our numbers here. Well, the perimeter we were given is 84. And that's equal to 2 times the quantity of 4x plus 3x, which we can just call 7x. Again, two options. I like moving this 2 over to the other side because then I'm dealing with smaller numbers. 8 divided by 2 is 4. 4 divided by 2 is 2. And then you've got 42 equals 7x. Last step here, we just got to divide by 7 on both sides, and x equals 6 for our factor. So taking this back and filling in our length is going to be 4 times x, or 4 times 6. Which gives us 24. Again, we've got a label of feet for this problem. And then our width was 3 times x, or 3 times 6, which gives us 18 feet. Length and width for that problem. Again, be sure you do your 2 checks to make sure that your problem turned out the way you wanted it to. 24 doubled and 18 doubled should add up to 84, and they do. And then 4 times our 6 gives us 24. 3 times our 6 gives us 18. They reduce back to that same ratio. Our next example deals with a triangle, JHK, and the ratio of the angles this time is 2 to 3 to 4. What we want to do is find the measure of all of our angles here. Okay, so again, I'm going to sketch a picture here of a triangle and label my vertices J, H, and K. Now, since the order of my vertices went J, H, K, I'm going to think that's the same way my ratio is being expressed here. So J is 2, H is 3, K is 4, but then again, we want to put an X on all of those because those aren't the actual measures of our triangle. And you know that because the measures of a triangle have to add up to 180 degrees. And in fact, that's how we'll find the measures of the angles themselves. We'll set up an equation, 3x plus 2x plus 4x, whatever order you want. We know that has to add up to 180. Right? If we combine our like terms here, we've got 4, 5, 6, 7, 8, 9x equals 180. Go ahead, divide by 9 on both sides, and x equals 20. That's the factor that all of these have been reduced by, so we just have to substitute back in to go find our angles. Well, this one is 2 times 20, which is just 40 degrees. This is 3 times 20, which is 60 degrees. And we've got 4 times 20, that is our 80 degrees. Now, if you draw your picture, I'll let you keep it just like this, and I can see which angle goes with which number. Okay, without a picture, we'd have to write it in the same order of the ratio we're given so that we know which angle corresponds with which number there. So our J here was 40 degrees. The next one was our 3x, which is our 60 degrees, the H in our triangle. And that last one, K, 4x, is 80 degrees. Okay, and that's another way you can express your answer. Number 11 talks about the ratios of the sides of a triangle, and again, we're given the perimeter since we're dealing with sides. So, again, first sketch your triangle, and then we need to label the sides with these ratios. We've got 8x, 15x, and 17x. We know that the perimeter, when we add up all these actual numbers, should come up with 480. What we have to decide is what number is this x? What are we multiplying all these by? Okay, so very similarly, 8x plus 15x plus 17x equals the perimeter of our triangle, in this case 480. Okay, if you remind yourself, the perimeter of a triangle is just A plus B plus C. There's no guarantee that any of our sides are the same for a triangle, unlike for a rectangle. So all we have to do is just add up all of those side lengths. So when we actually do that, go ahead, combine like terms. 8 plus 15 plus 17 should come up with 40x, and then that's equal to 480. We need to get x by itself, so we're dividing by 40 on each side. Again, you can always cut off extra zeros, and then we've just got 48 divided by 4. So x is equal to 12 here. Alright, so our factor is 12. We just have to go substitute these back in. 8 times 12, 15 times 12, and 17 times 12. Okay, pause the video and go get those values. So, for this one, if you notice, if you have a picture, you can go ahead and label in the side, but we're not given names of this triangle. So what I would like you to do is express your answer in the order that we're given in our ratio. So 8 came first, so we will take this 8 times 12, the 96, hopefully you came up with, inches for our first part of our ratio. The second one is the 15, so we're using 15 times 12. That's 180 inches. And our last one, 17 times 12, that's 204 inches. Notice I have a label on all of these pieces. It's how I'd like you to write it. Alright, the next one are solving proportions. Okay, a proportion is different from a ratio because if you notice, we've got an equation or an equal sign in our problem. We can solve proportions by cross-multiplying. You should be familiar with this from Algebra 1. Cross-multiplying just means we go across the equal sign diagonally. So we will take 3 times 8, which is 24, and copy down that equal sign. That should be the same thing as x times 6 or 6x. All we have to do is divide by 6, and x equals 4. Now, if we go back and look at our original equation here, you'll notice this 6 divided by 8 on the right-hand side actually reduces to 3 over 4. And then we have 3 divided by x equals 3 divided by 4. Well, from that, we know that x has to be 4 since x is the only thing on that denominator there. They have to match up. Okay, but that won't always happen in proportions, so this cross-multiplying is going to be important for how we solve these types of problems. Now, if you look at the next one, you'll notice that the variable is not alone. We've got y plus 2 in the numerator of this second half of our proportion. Any time that you have more than one term, you'll want to go ahead and put parentheses around it. That tells us all of that has to be multiplied when we do our cross. So again, we will start with 5 times 6, which is equal to 30. And then I've got 3 times this quantity, and I will write it just like that. 3, and then my parentheses, y plus 2. Now, there's 2 ways to go ahead and solve for y, just like we did with perimeter here. If you notice, this is 3 times the quantity y plus 2. Well, if we're multiplying on this side, if we want to get rid of that 3, we could actually divide it away. And then that's gone, and this 30 divided by 3 becomes 10, and then there's no need for these parentheses anymore. It's just y plus 2. Now we can get y by itself pretty easily. Subtract 2 from both sides, and y equals 8. Now, most people, that's not what they would see back up here to solve that, is they'd want to say 30 equals 3 times the quantity y plus 2, and then distribute this 3 through. That's perfectly okay. We've got 30 equals 3 times y is just 3y. 3 times 2 is 6. So next we would just subtract that 6 over. And we've got 24 equals 3 times y. Divide that 3 off of there. And you get y equals 8. Same exact answer, 2 different ways to do it. Either of these is going to work. If you notice for this first one, we didn't take as many steps as the second one. But the only reason I wanted to move this 3 over is because I saw that 3 was going to go into 30 evenly. That's not always going to be the case. So distribute every time it works. This time we only want to do it if the number is going to go into the other one evenly. Okay, so let's check out the next one then. We've got m plus 2. Again, anytime there's something more than just a variable, we want to make sure that we put it in parentheses. And then we will cross multiply again. Now, I'm going to choose to write this 10 first, just like I wrote the 3 first over here, and say that's 10 times the quantity m plus 2. And I'll set that equal to my other cross on this side as 70. Now, from this stage, if you remember from over here, I'm going to look, does this 10 go into the 70 evenly? If so, your life becomes easier, and in this case, it does. Before you distribute, ask yourself that question, and you might save a step. So this is just n plus 2. Extra zeros go away. You've just got 7 left here. And then we'll subtract that 2 from both sides to get n equals 5. Okay, go ahead and pause the video and take care of 15 and 16. On number 15 here, 1 times x is just x, and we've got 2 times 28 as 56. This one was pretty easy to figure out based on 1 and x being by themselves there. The next one is very similar though. We've got 3 times 24, which is 72, equal to 8 times y, or 8y. Dividing by 8 on both sides, we have y equals 9. Now, what I'd like to show you is something cool about proportions here, is let's notice a pattern here. On this side, we said that x was 56. Well, that comes from, if we read this straight across, 1 went to 28. Now, when I say went to, I mean 1 was multiplied by something to get to 28. Well, that something is 28. So that means 2 has to be multiplied by that same number to get to x. So if I take 2 times 28, I better get 56. And that's exactly what we did to solve for x here. Same concept works here. We don't know how to get from 3 to y, but if you look at the bottom, 8 times some number would get you to 24. That some number is 3. So if we multiply by 3 on the bottom, we should do that same thing on the top, and 3 times 3 is 9, which we got using that cross multiplication. So if you can see that pattern, you don't necessarily have to use this process to solve. Alright, 17 is a little bit tricky because we've got a numerator and a denominator that have 2 terms in them. That's okay, our process still stays the same. Now, what I'd like you to notice, on this right-hand side over here, I've got a 30 and a 10. If you've got extra zeros, you can cross them off immediately. That's going to make our life easier to solve here so we don't have to deal with as big of numbers. So now I've got 1 times the quantity x plus 22, my first cross. And then my second cross is 3 times the quantity x plus 2. Now in this case, there's nothing to divide away here, so what we're going to do is go ahead and distribute through. Well, 1 times anything is just itself, so x plus 22. And on the other side, we've got 3 times x, 3x, and 3 times 2 plus 6. We want our x's to one side. I'm going to move this single x over. That keeps the coefficient on the x positive, which is helpful. And then we'll subtract 6 from both sides. And 16 equals 2x. Last step, go ahead, divide by 2 on both sides. So x equals 8. Now let's go back up to our original equation. We can kind of check ourselves here. If you look, 8 plus 2 is 10 on the bottom there, and 8 plus 22 is 30, so we did our job right. Okay, the next few problems are applications of ratios. Okay, we've got Brian measuring plants in a field for a science project. Of the first 24 plants he measures, 15 are smaller than a foot. If there are more than 4,000 plants, or if there are 4,000 plants in the field, Predict the total number of plants smaller than a foot in height. We're going to set up a proportion to solve this. Well, if you notice, we're really only comparing two different things. Plants and plants that are smaller than a foot. Okay, so there's our sample with those two. Our second sentence was talking about 4,000 plants, and we want to know how many are smaller than a foot. So what we want to do is talk about those two things separately. Plants and the ones smaller than a foot. Because we've got a top and a bottom for our proportion. So the number of plants in the first ones he's looking at were 25. Of those 25, 15 were smaller than a foot. So we can say the total number of plants to the ones smaller than a foot is 25 to 15. Well, if that's the order we're comparing those, we want to do the same thing for our next set. The total number of plants in our next set was 4,000, so that will go on top. And we want to know what was the number of plants smaller than a foot. On bottom, we want to know, so we'll put a variable there as x. Now it becomes a proportion that we can go solve for x. We'll take 25 times x and set that equal to 15 times 4,000, 60,000. And then divide by 25 on both sides to get x equals 2,400. And in this case, we're talking about plants, but since our original was just plants, we want to make sure that we specify it's the ones that are smaller than a foot. So plants that are less than 1 foot. Now, if you notice back up in our proportion here, 25 over 15, we could actually have reduced to 5 over 3, and then we would have dealt with smaller numbers here. But just like when we're dealing with fractions here, we're going to come up with the same factor as long as we reduce correctly there. So if you don't see you can reduce, no big deal. Now on number 19, we have Mayor Hernandez conducting a survey of voters. Now 200 voters were total, and out of those, 135 approve of the job she's doing. Then we've got 48,000 voters in the town. We want to predict the total number of voters who approve. Okay, so again, we've got to be comparing two different things. The first thing is just voters. The second one is going to be those voters who approve. Now, it doesn't actually matter which one that you put on top or which one that you put on bottom, so long as you are consistent. That's why I'd like you to go ahead and label what the two things you're talking about are, so that your numbers line up like they should. So, total voters for the survey was 200, and out of those, 135 approved. And then total voters for the town was 48,000. And we want to know how many approved based on that. So let's see for this one if we can reduce anything before we get started with our solving by cross multiplication. Well, if you notice, this 200 and the 135, it can actually be reduced. In fact, it reduces to 40 over 27. Now, a lot of people aren't going to see that as quickly as just cross multiplying. So a problem like this may not necessarily save you any time by reducing. And if you end up with the same answer, we're hoping to save some time or make it as easy as possible. Now, when we cross multiply here, at least we'll have smaller numbers. We've got 40 times x, and then we will just have 27 times 48,000. Grab that number. $1,296,000. And then divide by 40 on each side. You can cross off an extra 0 if you want. So x equals 32,400. Again, we want to put a label on this. It's not just voters, it's voters who approve. Based on those two problems, pause the video and see if you can figure out 20 and 21. Now, notice on 20 here, we've got 3 DVDs costing $44.85. Find the cost of 1 DVD. Most of us are able to figure out what to do without actually setting up a proportion. Okay, if 3 are going to cost $44.85, if we want to find the cost of 1, all we have to do is divide that by 3. Okay, but I'm going to show you where that comes from in terms of cross-multiplying to solve proportions here. Okay, so we're comparing DVDs and cost. So DVDs, we had 3, and that was $44.85. We want to know 1 DVD costs how much? Well, that's 3 times x equals 44.85. So in fact, all you have to do is divide by 3. It's just showing you that you can use proportions to solve a lot of different types of problems here. Okay, 21 was comparing male to female students. Now, in the drama club, we have the proportion 3 to 4. So, female, or male to female is 3 to 4. So, 3 over 4. We know that the actual number of male students is 18. That'll go on top with our 3. And we want to know how many female students. That'll go on bottom with the 4. Now, I actually think this one's easier to solve without cross multiplication. If you think 3 times what number gives you 18, well, that number is 6. To do the same thing, we would say 4 times 6. We should get x equals 24. Now, let's see if that works with cross multiplication. 3 times x equals 18 times 4, which is 72. Divide by 3 on both sides, and x actually does equal 24. Sometimes it'll be easy to see the pattern and you don't have to cross multiply, just like over here. You could probably see that you just need to divide by 3 to solve that. Again, we want to put a label on here. We're talking about female students. That is the lesson on ratios and proportions. If you have any questions over what the video covered or on the homework, be sure to come and ask me.